Okay, so let us now discuss the properties for divergence and curls. For that, if we assume let vector f and vector g be vector point functions, so these are given to be vector point functions, and phi is given to be scalar point function. At the position x, y, z. Then the first property is del dot vector f plus minus vector g, that is equal to del dot vector f plus minus del dot vector g. So that means the divergence of the sum of two vectors is equal to the sum of divergence of two vectors individually. So this is the first property. The second property is that when you take the divergence of phi of vector f, that is equal to, so that means whenever you take the divergence of two quantities, one is vector, one is scalar, so that is equal to the gradient of phi, because phi is what? It is a scalar quantity. So you cannot perform the dot product here, so you have to take the gradient only. So this dot with vector f plus phi as such, the divergence of vector f. The third property is that whenever you perform the divergence of some gradient of phi, so this is equal to del square phi. Now this del square, this is another operator. So this del square, this is the operator which is defined in terms of double derivative. So it is del by del x square plus del square by del y square plus del square by del z square, and this is known as the Laplacian operator. This operator is very useful in many applications. For example, whenever you wanted to solve the heat equation, you will see this kind of operator here, right? In mechanical you will see this heat transfer topic, so there in heat equation you will see this operator. Moreover, in wave equations also this operator comes, so it is very important to know what is this operator. Okay, so next property is about curl. It says that whenever you take the curl of the sum of two vectors, so what is this equal to? This is equal to the curl of vector f plus the curl of vector g. This is very simple, right? You can very easily prove this. Next is when you take the curl of the product of two functions, one is scalar point function, one is vector point function. In that case, this is equal to, because you cannot take the curl of a scalar function, so it would be the gradient of function phi cross product with vector f plus the vector scalar vector, this scalar function phi as such, and the cross of vector f, right? The next property is about taking the cross curl of two vectors, right? Curl of cross product of two vectors. Now this is equal to vector g dot, so this second vector comes out first. Now here the order matters very much, so you should be careful while writing this or using this property. So here it is equal to the second vector dot with the curl of first vector minus the first vector dot with the curl of second vector, right? So when you take the curl of cross product of two vectors, so that would be second vector curl of first vector minus first vector curl of second vector. And
ma'am,
so here this property is whenever you take the del dot vector f cross vector g, So this is the result. That means you perform the you take the second vector as such, then take the curl of first vector minus first vector, then the curl of second vector. So this is this property. The next property, seventh property, that give you the curl of cross product of vector f and g. So what is this property? This says that you take the dot of the second vector with del, right, and vector f as such, minus second vector g del dot f vector minus f vector dot del vector g, and the last quantity is plus vector f del dot g. So you see, you have this quantity and this quantity with the order of f reversed, and then you have this minus of this and minus of this with the orders reversed, right? So this is your seventh property. We have few more properties. We'll discuss them, right, later on. Okay, the eighth property here is del of vector f dot with vector g. This is equal to vector g dot with del into vector f, whatever is the result, into vector f, plus vector f dot with del into vector g, plus the vector g cross with the curl of vector f plus the vector f cross with the curl of vector g. So this is the eighth property that we have. So that means the gradient of the dot of two vectors, that is equal to second vector dot with del into f, first vector dot with del into g, plus the second vector cross with the curl of f, and the first vector cross with the del of g. So this is our eighth property. For the ninth property, it is equal to half del of f square. Now this is equal to, so this is equal to the vector f dot del vector f plus the vector f cross del cross f. So basically this comes from this property only, where you just replace this g with f. So that means we are doing this del f dot f vector, right? So here it would be f vector dot del f vector, right, plus f vector dot del f vector, so it becomes 2 times, right? And here also we have vector f, the curl of vector f, plus vector f, the curl of vector f. So everything becomes 2 times. So we have half of del f square. This is equal to this quantity, right? So this is our ninth property. Or you could also write the same property like this. So you could also write this to be the vector f dot with del multiplied with vector f. This is equal to half del of vector f square minus vector f cross with the curl of vector f. So this is our ninth property. Moving on to our 10th property, it says that whenever you take the cross of the gradient of phi, so gradient of phi you know is a vector quantity, you can take its curl, this is equal to 0 always, the vector 0, right? So in other words, you could say that curl of any gradient, this is always equal to the vector 0. And the next property is the divergence of the curl of some vector. This is equal to 0, because divergence always results into a scalar quantity and this should be a vector, right? So we can write the divergence of curl of some vector f that is always equal to 0. So this is the property and you should remember this one. The last property here states that if you take the curl of vector f, this is equal to del dot vector f minus del square vector f. So this is the last property. So you could try to prove all these properties by yourselves. The proofs are pretty simple, and moreover you should remember them, as using these property become quite useful in some cases where typical calculations are otherwise required to be done. So I hope you understood this concept well. Well, that is it for this video. Thank you for watching.